Okay, here's what's happening. We've got this 11-foot piece of wire that we're cutting into two pieces. One of them we're representing with the letter X, so the other one has to be representable by the expression 11 minus X. We're going to turn the X portion into a circle. That means the circumference of the circle is going to be X. And we're going to turn this into a square, which means the perimeter of the square is going to be 11 minus X. And what's happening is we change the value of X, the size of the square and circle change. As a matter of fact, if I go to Desmos, where I've let X sub 1 equal the length of the wire that we're going to cut into X, as I increase X, the square gets smaller and the circle gets bigger. And as I go this way, the circle disappears and the square gets bigger. And we want to know, where should I cut that wire so that the sum of the areas of these two shapes is a minimum value? Okay, that's where we're headed. So what we need to do is come up with a function that defines the sum of the areas of these two shapes. And here's a way to think about it. So this X piece of wire, I'm bending into the shape of a circle. That means the circumference of the circle is X, but the circumference of a circle is 2 pi times the radius. So if I plug X in for the circumference right there and solve for R, I will have the radius, an expression for the radius of the circle in terms of X over 2 pi. But the area of a circle is pi times the radius squared. And you could leave it like that, or you could square this X over 2 pi and simplify. That's how I'm going to write it right there, X squared over 4 pi. As far as the square goes, the total perimeter is 11 minus X. Since each side of a square has the same measure, then one side has to be 11 minus X over 4. That's one side of the square. And the area of a square is side squared. So if I take this expression and square it, I'll have the area, the expression that represents the area of the square. So the total area of the circle and the square is represented by, here's the area of the circle, here's the area of the square. I want to find what value of X will make this function have a minimum value. So I find the first derivative, so that I can find the critical numbers. Where does it equal 0? I probably want to kind of at least think about the fact that the critical numbers generate a minimum value. But if I take the derivative of this first term, bring the 2 down front, 2 over 4 pi is 2 pi in the denominator. I can bring this 2 down front. 2 over 16 is 1/8 times 11 minus X, reduce the exponent by 1, and then multiply by the derivative of the inside chain rule. I could also square this binomial and go term by term, 121 minus 22X plus X squared. In passing, I'll take the second derivative, and note that the X's disappear when I take the second derivative. So the second derivative shows that it's always positive, which means the function is concave upward, which means any critical numbers will generate a minimum value. Okay, so I want to know, when does this first derivative equal 0? So here I've distributed this -1 times an eighth is -1/8, and then I've distributed. That's where I ended up with these. I multiplied every term of this equation by 8 pi to clear the equation of fractions. So 2 pi into 8 pi is 4. 4 times X is 4X. Here I get minus 11 pi plus pi X, or X pi equals 0. How do I solve for X? Add 11 pi to both sides. Factor the X out from these two terms. And finally divide by the coefficient of x4 plus pi. There is your minimum value. And we know, or there's the X value that gives you a minimum. If I go back to Desmos Here is that same function for area. If I show it right here, there's the minimum value right there. That is 11 pi over 4 plus pi, 4.839. And here's a little table showing you that as x value goes through these values, then it looks like 11 pi over pi plus 4 generates the minimum total area, 4.2357498. Any other number that you cut the wire at x will give you a larger total area. Okay, hope that helps. If you have a comment, a question, post a comment. There you go.